My name's Imran. I work as a data scientist in the public sector. I've been doing that for close to 3 years now. Before that, I worked as a mechanical engineer, also close to 3 years. I have a bachelor's degree in mechanical engineering from UQ and a master's of data science from James Cook University. What I love about data science is that it combines a number of different fields that I enjoy, which include computer science, math, and statistics, and even business. And what I also love about data science is that it's an incredibly research-oriented field that is also equally concerned about incorporating that research back into practical applications that solve problems. And on top of all of this, it's relatively easy to get started building data products. You know, having started off in mechanical engineering, if I wanted to build anything from the theory that I'd learned, I'd have to have access to like a physical workshop or money to purchase materials. But in data science, that's not really the case. All you really need nowadays is a cheap laptop. And yeah, those are the reasons that attracted me to data science in the first place, away from engineering. So all my tasks revolve around developing, deploying, and migrating AI solutions for fraud detection. So with that, there's a lot of coding involved with Python, R, SQL. And on top of that, there's also a lot of communication between different teams within business. So I have to work with project managers and business clients to make sure that what we're delivering actually meets the specifications and the requirements of what we're set out to do. So no 2 days are the same in data science. You're exposed to new problems every day that calls for different solutions. So when a problem calls for different solutions, you're going to be relying on different data science techniques to solve that particular problem. So yes, every day is different. And even in solving one problem, there's different phases throughout that life cycle as well. And so the challenges you'll face day in and day out will vary. When you're building a data product, you go through different phases of the life cycle. And so at the beginning, you might be concerned with different problems to what you'd be concerned with midway or towards the end. At the beginning, you're more so concerned about how you're going to collect that data, how are you going to engineer that data to be more usable. Then you can shift towards how do you optimize the model so that it's trained well enough to do what you want it to do and is also optimized in the way that you'd like it to be used in production. And then once you've got a working model, you're then concerned about deploying that model so that it can be used in production. And throughout that whole phase, there'll be varying degrees of communication with different teams, making sure that what you're building is meeting the specifications that have been set out. Part of the life cycle is extracting the data. And so the databases is one source where you can extract data. Data scientists aren't typically involved in setting up databases and the data modeling side of things. That's done by a separate team. But then once that data is there, data scientists are responsible for taking that data and then providing actionable insights from that data. I would say by and large, a data scientist focuses on predictive modeling. That's the key difference. So you're going to be working in programs such as Python and R and building data products that can make decisions on their own, whether that's through classification problems or forecasting. So back when I graduated high school, there wasn't a bachelor's in data science, but nowadays there is. So if you're interested in becoming a data scientist, you can look at studying a bachelor's degree in data science. But beyond that, you can also look at other sort of quantitative disciplines like math, statistics, and engineering. That would be fine as well. So with data science, you're taking that math and statistics that's relevant to data science problems, but you're also incorporating computer science. So combining code with the math. Whereas with math and statistics, you're more so focused on just the maths, just the statistics. There is some coding in MATLAB, but the coding that you would do there isn't quite the same as the coding you would do if you were to start with a data science degree. In a data science degree, you'd be focusing on languages like Python and R, and the problems would be focused on different things as well. Originally, I decided to study a master's in data science because I wanted to get my foot in the door of data science after having worked in engineering. And I thought that the best way to signal to prospective employers that I was serious about making the transition from engineering to data science was to undertake some studies in that area. And I think with the goal that I set out to study a master's, it did its job. I ended up landing a job as a data scientist after having completed the master's degree. It was also really a good way to practice a lot of the problems. I think the best way to learn data science is through the problems that you're exposed to. And so that regards, it was good. Absolutely not. So data science is really broad. You can choose to make data science your primary job, or you can go into things like marketing or healthcare where data science is like a portion of what you can do. So it doesn't have to be your all-encompassing job. And especially with the different subfields in AI, you got natural language processing and machine learning and deep learning. Specializing in each of those subfields requires a whole body of knowledge that, if you get tired of one thing, you can move on to different sort of problems and learn new skills. So it's the possibilities are really endless in data science, I think. Natural language processing is all about making sense of text data. Getting computers to understand text can be quite challenging, and so natural language processing focuses on that sort of problem. And then machine learning and deep learning are similar in that you're focused on like classification problems and regression problems, like forecasting problems. Machine learning is less complex than deep learning. Deep learning is when you get into like more of your multi-layered models that are more abstract. Yeah, so I think the three key soft skills would be communication, critical thinking, and innovation. So communication, in the job, there's a lot of instances where you have to collaborate with other data scientists, but also with stakeholders that aren't technical. So that could include like project managers and business clients. And with that, the aim is to communicate ideas simply, but not communicate them in the way that you dumb things down. And also, because building data products requires input from a whole bunch of different teams and disciplines, effective communication and getting all that right and putting all those ingredients together properly into a data product is really important. And I think critical thinking is really important as well, because a lot of the things that we do in data science are trying to progress what we've already done. They're sort of new things, and sort of you're going to come across instances that you probably haven't sort of experienced before, and sort of reasoning your way through those problems is a really important skill to have. And then for innovation, I mean, with data science, we're all about improving what we've done before, iterating over what we've done in the past, and being able to innovate and propose new ideas that drives things forward is really important in the role, I think. With data science, there's a mix between independent work and then collaboration. There's a strong mix. So some days you'll be working on isolated coding problems on your own, maybe working through how you're going to improve a model on your own as well. But then there's other times that call for collaboration. Maybe you're going to be working on a really large data science project, which involves collaboration with other data scientists. But then also, whatever you're building for business. So making sure that you're having those communications with business and making sure that what you're delivering meets their needs and provides business value is really important. So that does call for really strong communication with different teams that are not just in your data science internal team. Data science, people skills are a must. As a data scientist, you're going to be exposed to Python, R, SQL. SQL is another one, so querying. And then also, there's a big push towards cloud use and deploying models on cloud. So a good understanding of AWS, Microsoft Azure, those sort of cloud platforms, I think will set you apart as a data scientist trying to get into the industry. Yeah, so there does exist an online community platform called Kaggle, which hosts free data science projects. And so I think getting your hands dirty in projects is the best way to learn those soft skills as well as the technical data science skills that you're interested in. I'd recommend setting up a GitLab repository, which is a place that you can store your code so that you can build a portfolio of works that can be referenced back to. When you're applying for jobs, that's sometimes one of the things they ask for is to see your GitLab repository, to see the portfolio of work that you've been involved with. And apart from that, I mean, I would recommend finding a problem that interests you in the world and seeing whether you can solve an element of that using data science, doing your own research, maybe joining a team and solving that problem together. It's okay if you're not good at coding or data science today and you're interested in data science as a career. I remember in high school, I wasn't a natural at math and science, being honest. And I went on to really loving math and science because I kept at it and I kept practicing. I graduated with a bachelor's degree in engineering with first class honors. I graduated with a master's degree in data science with distinction. it gets to a point when you just keep practicing it that it just gets easier and easier, and it just becomes more natural. Practice is the best way to get better. Coding is a big part of the data science job, and so I wouldn't recommend not focusing on it. It's definitely something that's something key to focus on and practice with, but it's okay if you're not a natural just yet. I didn't actually do any coding in high school. My first introduction to coding was during my mechanical engineering degree, and even then it wasn't that involved. It was just enough to get me started and to sort of question whether it was something I was really interested in. And then I just practiced on my own. You find different projects that interest you, and you just build end-to-end coding pipelines. I think with the data science projects that you work on, there's a lot of time spent coding and thinking of all these different edge cases. And once you deploy that finished data product into production and seeing the business value that it brings in, that's the most rewarding aspect of the role, to see all that hard work pay off. And also to see how much business value that comes back from these skills that you've learned and that you enjoy doing. There's immense business value that can be garnered through data science techniques, and that's really exciting to be a part of. In data science, so it's all about discovery and trying new things, and sometimes you can come up with a really exciting idea that you're really interested in progressing, and then during that initial stage you'll sort of do some sort of discovery to see whether it'll actually pay off, whether it'll actually translate into business value. And sometimes when that doesn't pay off, you can feel a bit disheartened because you really were interested in seeing it all the way through. That's probably the least rewarding aspect of the role, but it's a necessary part of the role. Well, data science is ever evolving, and I think the technologies that incorporate data science is increasing in the market, and with that comes evolving regulation. So in the face of ever expanding technology, how is regulation going to keep up with that? And then in return, when a regulation is put in place, what things do we have to think about in order to make sure our data products are ethical, that you can trust the source of, that it's not biased? And also with data science, it's a really powerful tool. Some of the things you can do with data science can be quite challenging. Like, for example, deep faking an image or a video, to make it look like someone says or does something that they haven't. How do you deal with that? As data science gets better and better, and we're able to do more and more things, how do we rein that stuff in so that it's not causing harm to society? Data science plays a key role in driving forward a number of different industries. So if we look at healthcare, for example, data science is being used to identify and predict diseases and also recommend treatment programs. Data science plays a key role in personalized medicine. So, I wear a smartwatch. It tracks my heart rate, the steps that I take. That information can be used to predict health concerns or flag health concerns, so that I can go see a GP or go to a hospital. Data science also plays a key role in energy supply and distribution. So as we shift away from coal to renewable energy, part of tracking how much energy we're going to get from solar or wind will come through weather forecasts. And data science is really key to doing that. Data science also plays a key role in logistics. So optimizing routes, transportation routes, forecasting weather, which has an impact on transportation, as well as traffic congestions on different roads at different times of the day, different parts of the year. And data science plays a key role in banking and the government through fraud detection and risk assessments. There's a lot. I think another interesting application is in marketing as well, where data science can be used by a business to tailor their marketing campaigns to target ideal customers that they're interested in, make marketing campaigns more effective as well. I think the biggest thing I can recommend is to start a portfolio of work, get practice with Python and R. If you have a laptop, you can do a lot of things in terms of building data products like right now. You don't have to wait. There's a lot of good training material online that can get you started. There's Kaggle as well, that online community platform that hosts those data science projects. Just get involved as quickly as possible and start building a portfolio of work. If you're in a position where you've just graduated high school and you're thinking about what you want to do, and you decide to study data science, Definitely recommend doing the bachelor's degree in data science, but then after that, I'd probably recommend getting into the workforce as quickly as possible, because in my opinion, you sort of learn skills for the job while on the job, rather than through additional study. So some companies can have a data science division. Some companies can just specialize in data science service. So the companies that just focus on data science, you're looking at like consultancy firms that sort of provide their services, their data science services to other companies. And then some companies can just have their own internal data science department. They're equally common, yeah. There's equal opportunity to both work in an organization that has their own data science department, but also in consultancy that offers their data science services to other companies. Data science almost encourages you to work in different industries, because as you work in different industries, you gain domain expertise in that, or domain experience in that industry. And once you get that, it's really empowering, because it allows you to understand the problems that those industries face. The best way to solve problems is to understand the problem in the first place. And when you're working in those industries, that gives you exposure to the problems that they're facing. I think the best way is to keep abreast of the different companies that are involved with data science, and just check for updates of if they're looking for interns. And when they are looking for interns, do your best to tailor your application and submissions to what they're looking for. And then again, apart from that, building your portfolio of work so that you can showcase the skills that you've developed over time.